Hello students. In the previous lecture, we have learned about the salts and its pH. So in this lecture, we will learn about some of the common salt and its uses and its preparation. The most common salt is sodium chloride, and that is we are calling it common salt. The properties of it, the chemical formula of common salt is NaCl, sodium chloride. This salt is made up of which acid and which base? We can predict it from the formula only NaCl. So it will be made from NaOH base, sodium hydroxide, and HCl acid. From this salt and from this acid and base, this NaCl is formed. So this salt is commonly used in kitchen, extensively used in kitchen. Okay, but it is also used in preparation of some other salts, some other components, some other compounds. Okay, so which compounds? First one, this salt NaCl is used to prepare NaOH, that is sodium hydroxide. Okay, this and the preparation is known as chlor-alkali process that we are going to learn. This NaCl is also used in the preparation of bleaching powder, then after baking soda, washing soda, etc. So other important components, other important substances are prepared from this NaCl. So it is a very important raw material, we can say it. Okay, so let's see the chlor-alkali process to prepare NaOH, that is sodium hydroxide, and commonly also call it caustic soda. Okay, NaOH is also commonly called caustic soda. So this is the arrangement of for the preparation. This cell is called the electrolytic cell. Here the electrolysis process will occur. But in this electrolytic cell, there are two electrodes. One is positive, one is negative. Positive is called anode and negative is called cathode. And between these two, there is one membrane. Right? This membrane is ion permeable. Remember, what do we mean by ion permeable? Ion permeable means ion can pass through it because this membrane is porous, so ion can pass through it. So, and particularly positive ion only. This membrane is made up of polymers. Okay, so this polymer is very special kind of polymer, and this polymer is only can pass the positive ion. When negative ion or electron cannot pass through it. Only it is the proton conductor. It means the positive ion can pass through it. Okay. So this is the membrane. Now from this NaCl, here the brine is entered through in the electrolytic cell. Brine is the solution of NaCl. Okay, common solution of common source. So NaCl plus water. Okay, so brine is added here, and here from it here water is also added. So this cell contains the NaCl solution, NaCl plus water. Now this electrode, one is positive and one is negative. Due to this positive electrode, the NaCl will be dissociated, so NaCl will be Na plus and Cl minus. We can know that. So chlorine negative ion attracted towards the positive electron, okay, and negative ion means it has extra electron in it. So this extra electron will be given to is attracted towards given to this positive electrode. So at anode, which process is occurring? Cl minus giving the electron, one electron each. So two chlorine ions giving two electrons, and after giving the electron it becomes neutral, that makes Cl2. So at this chlorine, Cl2 gas will be accumulated and that will be collected from the upper side. Now this Na plus can pass this positive ion attracted towards negative electrode, and here as the water is coming and there is a solution, water is inside the solution, this water due to the effect of this electrode will be dissociated into H plus and OH minus, right? So water molecule is dissociated in H plus and OH minus. So H plus positive electrode will be attracted towards negative electrode. Positive ion is attracted towards negative electrode. So H plus will be accumulated here. And negative electrode having electrons, right? Because it is negative, so electrons will be H plus. So at cathode, that is a negative electron, which process H plus gain one electron, making H atom. So 2H plus getting 2 electron each and making H2 gas. So H2 will be collected here and that will be taken from the upper side. Now remains OH minus and Na plus. This OH minus should attract towards a positive electron, but this membrane will not allow this OH minus to reach to this positive ion because it cannot pass through this membrane. But Na plus will be passing through this membrane and coming here. But before it go to the negative electrode, it react with react with OH negative and makes NaOH. Okay, sodium atoms are passing through this membrane and reacting with OH minus hydroxide ion. So NaOH is made, and that NaOH. So OH is not going to that side, only Na plus is coming this side. So this section, this part of the cell having NaOH, and that NaOH will be collected. The solution will be collected and then NaOH will be collected from it. So that NaOH is collected from this side. Okay, so overall, what if you want to write the reaction here? So NaCl and water giving chlorine gas, hydrogen gas, and remaining NaOH. Remaining ions will be making NaOH. Okay, so this is and this process we are calling it chlor-alkali process. Why it is called chlor-alkali? Because chlorine is made here. Chlorine is as a product, and alkali means base. Okay, so generally, why alkali is called base? Alkali are the base which are soluble in water. Okay, only not all the bases are soluble in water, but the base which are soluble in water or which can make the aqueous solution, that base are called alkali. So here alkali NaOH is made and chlorine is also made. So we can call it chlor-alkali process. This is the simple mechanism, and the result, so chlorine gas collected on the upper side, that chlorine will be used in different various uses, and hydrogen gas is also used in different activities, and NaOH is also used in different functions as a base and different works. Okay, so this I think this was the simple mechanism of chlor-alkali process. So read it, and if you have any doubt, you can ask me. Thank you.